Hello, Bruce Fulton here. Welcome to my fourth and final lecture on database normalization. I'm going to talk briefly about the fourth normal form. I'm just going to give you one example to illustrate what's going on. A lot of lectures you see on YouTube and even in some textbooks tend to skip fourth normal form. When it is presented, it's often presented using fairly complex mathematical notation. I'm going to skip that. I really just want to give you an idea of what's going on and how to deal with it. You don't run into it too often because when you set up databases, it's kind of natural to avoid setting it up in a way that it's a problem. It's kind of intuitive, I think, to avoid violating fourth normal form. But I'm going to show you what it is so you know to avoid it, show you what the problem is, and we'll skip the math for now. So let's just take a look at what it is and what people are talking about anyway. So formal definition is a relation is in fourth normal form when it's in third normal form, and both of these mean the same thing. No instance contains two or more independent multi-valued facts about an entity, or there are no multi-valued dependencies. And so multi-valued dependencies occur when the relation is trying to represent more than one many-to-many relationships. So let's consider the case where we have a table about an employee. The employee might have many skills, and the employee might also have many languages. And the problem arises when we try to represent in the same table all of the skills and all of the languages that the employee might have. And of course, obviously, the way to deal with this is to break apart the skills and the languages. And so these are many-to-many relationships. And other examples, of course, that you can run into are students' courses, teachers. Students can have many courses and many teachers can teach the courses, suppliers, products, locations, and so on. So let me show you what happens and what the problem is. And I'm going to use an example I found on IBM's website. And I think their example even has a couple of problems. You have to kind of torture yourself a little bit to actually come up with this formulation. But we'll see where it goes, and I think you'll see what the problem is. So here we have an employee table that IBM suggests you might set up. And they don't show it filled in with data. But I've filled it in with data. And here you can see the problem. Employee 101 plays archery, plays badminton, plays darts, and also speaks French, German, and Chinese. And if we're going to put all of this stuff into one table, for each instance of archery, then we have to indicate in a separate tuple or row the fact that he speaks French. He plays archery, he speaks German, he plays archery, he speaks Chinese. Then we have to have another tuple or row that says he plays badminton and speaks French. He plays badminton and he speaks German. He plays badminton and he speaks Chinese. So you can see where this is going. We all of a sudden have a multiplicity of tuples or rows. And this gets to be a very unwieldy table. And we've got all this kind of duplicity here. Now, the problem I find with this example overall is that this really only makes sense if we view this as a junction table, because what I think is going on here is that this would be a junction table. So let me unhide what I think is going on here. And we would really have this employee table here, and we would have a skills table here, and we would have a language table here. And this would actually be a junction table, and we would be trying to toss all this into the junction table. Now, if this were actually a junction table, we'd have other problems here, because we have these descriptors in here that are not dependent on the primary key. And as you know, if we would have a multi-attribute key here, or a compound key, then including these would violate second normal form. So you wouldn't want to do this anyway. But I think this is the idea that's being set up here with this example. So clearly what the solution here that gets us out of a fourth normal form violation is just to set up multiple junction tables, because we have at least two many-to-many relations going on here. We have employee ID with skill code and employee ID with language code. And so again, leaving the descriptions in here just for the sake of illustration, but you wouldn't want to make your junction table look like that. We would split this into two junction tables, one with employee ID skill code, that would be one junction table, and another with employee ID and language code. So this would get us into a fourth normal form. And again, a lot of people skip this. I think it's important to know at least what's going on here and to know the terminology and so on. So I think this is enough of an example to get you to where you need to be with fourth normal form. If you have these situations where you have multi-valued dependencies going on, where the relation is trying to represent more than one many-to-many relationships, and this situation is common, you just need to build yourself multiple tables, and I think that's pretty clear. So with that drawing to a close, let's just quickly review the normalization summary, the steps you need to go. These proceed in order. First normal form is no repeating group. Second normal form, it has to be in first normal form. We have compound keys, at least two attributes comprise the key. No non-key column is dependent on only a portion of the primary key. Once we take care of any of those situations, we need to look at the third normal form, which is all the tables are in second normal form, and the only determinants are candidate keys. And then finally, fourth normal form has to be in third normal form, and no multi-valued dependencies. So I hope this series of videos has been helpful to you. We've tried to explain it in plain English. It can be a little bit more complicated than this. I certainly glossed over some of the details, but I wanted to get you a high-level conceptual overview of what these mean and the process by which you go through it. And maybe that'll give you a little bit more background knowledge so you can go into depth into some of the more detailed explanations about update anomalies and why you need to go through this process. So thank you very much for watching, and have fun normalizing. Take it easy.